This demonstration will give an overview of using MATLAB for algorithm development and programming. The MATLAB language and development environment provide many functions and tools for developing algorithms. To illustrate some of these features, we will look at an example of developing an algorithm to identify the lanes on a road, which is a component of lane departure warning systems in automobiles. Let's first read in an example JPEG image of a road stored in this directory. The image now exists as a matrix variable in the MATLAB environment. We can develop algorithms that visualize, analyze, and manipulate such data in a number of ways. These include using interactive tools launched from the development environment, entering MATLAB language commands in the command window, and creating and executing a program consisting of a sequence of MATLAB commands in the editor. Let's now display the image. Here we see the road scene and the lanes we need to identify. We will try identifying the lanes by their brightness level, so let's first scale the image to ensure the lanes are as bright as possible. Variables and numerical computation in MATLAB are double precision by default, but you can manipulate single precision and integer data as we will do here. Here we will create a new variable and display it by typing commands in the command window. Here we see the new variable and how it looks displayed. Let's now compare the image to a threshold value to try to extract the lanes. Here we see the lanes standing out more clearly. As well as entering individual commands, you can develop a sequence of commands to form a program in the MATLAB editor. You can create a program file from some of the commands you have entered already. Let's now edit our code. You can edit and execute sections of your code one at a time. You can iterate on values and expressions. And look at the result to find the optimum value. You can continue to add to your code to create a more complex program using all the features of the MATLAB language. The MATLAB language supports the vector and matrix operations that are fundamental to engineering and scientific problems. It enables fast development and execution. Next, we will open an example program that performs all the operations to detect the lane markings. First, we will remove the previous data. We will step through this example program one section at a time and see how it identifies the lanes on the road. In MATLAB, there are functions to read and write various types of data files. Here, we will read in our JPEG image. There are many plotting functions for visualizing your data. Here we use one to display our image. Next, we use arithmetic operations to scale our image. Then threshold it. You can call other functions from specialized add-on libraries. Here we will use commands from the image processing toolbox to remove all the small objects from the binary image. flow control statements available include loops, if-then-else, and switch case expressions. Here this code finds the boundaries of all the objects and highlights them in green. You can call other MATLAB functions that you have created yourself. Here we will call another function that determines which object boundaries are lane-shaped and deletes the ones that are not. Here we see the final result with the detected lanes overlaid on the original picture. You can also debug your code by setting breakpoints, single-stepping through your code, and inspecting variables when execution has stopped. Such as an element in this data structure. That concludes the demonstration. You can try these examples in MATLAB now, or watch one of the other videos.